So this time we are directly given h of z. Now this will make it little simpler because I can find out frequency response function directly. H of z is given as z inverse minus a upon 1 minus a z inverse. So let's put z equal to e raised to j omega and obtain h of omega. So h of omega will become e raised to minus j omega minus a divided by 1 minus a e raised to minus j omega. Now in this case, instead of finding mod h of omega of this particular filter directly, we will proceed in little bit different manner. We will first find h of z inverse. H of z inverse will be nothing but h of z, in which I will replace z with z inverse. So wherever we have z will become z inverse, and if we already have z inverse, then it will become z, because that negative power with one more negative power will cancel out. So h of z inverse will be nothing but this z inverse becomes z, so it's z minus a upon here it will be 1 minus a, again this z inverse will become z. I will next find h of z into h of z inverse. Let us see what will this turn out to be. H of z that we just now got is z minus a upon 1 minus az, and h of z inverse is z inverse minus a upon 1 minus az inverse. Now let us convert the second part, means h of z inverse, in the form of positive powers. So that will give me z minus a upon 1 minus az into this z inverse will be nothing but 1 upon z minus a upon 1 minus, this will also be 1 upon z. This will further become z minus a upon 1 minus az into, so this will become 1 minus az upon z, and this will become z minus a upon z. So both the z will cancel out, and this is what we get. If you observe, the numerator and denominator in both these parts are exactly same, so everything will cancel out, and therefore we get h of z into h of z inverse equal to 1. Now this leads us to interesting conclusion that mod h of omega squared magnitude function, which is given as h of z into h of z inverse, for this filter becomes 1. If squared magnitude function becomes 1, then if I take the square root, mod h of omega will also be 1. So this is what we ultimately want. We want the magnitude response, and you can see for this filter the magnitude response turns out to be a constant. It is constant irrespective of the value of omega. So even if I plot it, all I have to do is draw an horizontal line from minus pi to plus pi, because magnitude response is a constant value, and this simply means that the given filter is nothing but all pass filter, because you can see it allows all the frequencies to pass or come at the output side. So that's the solution to the second part. Second filter was nothing but all pass filter. Now how do we understand that we have to use this approach of finding mod h of omega? That is because when we were discussing all pass filters, we had made one very important conclusion, saying that whenever the filter coefficients in numerator and denominator appear in reverse order, then the filter will always become all pass filter. So right from the beginning it was clear that the filter is all pass, because if you observe carefully, the coefficient of first term is nothing but 1. The second coefficient is minus a. For the denominator, you can see the first coefficient of which is a constant term is 1, and coefficient of the z inverse term is nothing but minus a. So you can see the coefficients are appearing 1 minus a, and here minus a 1. They are appearing in the reverse order, and that means it is an all pass filter. So all you have to do is find h of z inverse, multiply it with h of z, and that will give you magnitude square function, which will always come out to be 1, and that will verify that the filter is an all pass filter.